Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So in this video, I'm going to discuss an example of a simple question for analysis, a simply supported beam, where in here, I'm going to list out what you are expected to do from this kind of question. Number one, you want to be able to calculate the support reaction. Okay, and then from support reaction, you should be able to straight away sketch the shear force diagram and bending moment diagram. Okay, so actually if we go to the next semester, in between here there is actually another step. You should be able to calculate shear force and bending moment. So basically you are supposed to calculate shear force and bending moment first, and then you are going to sketch shear force diagram and bending moment diagram from this value here. Shear force, we use symbol V, and for bending moment we use the symbol of M. Okay, capital M, capital V. Okay, but we're not going to do that in this syllabus, so I'm just going to show you how from support reaction we're going to sketch shear force diagram and bending moment. Okay, so to clarify, for our syllabus in this semester 1, okay, the coverage of the syllabus is only for a simply supported beam like this one, here. And I've mentioned in previous video what is the meaning of a simply supported beam. Now you can see it without overhanging. So if we have overhanging, we have a bit here, so it's overhanging, right? So it's overhanging. Okay, but we're not going to do that in this syllabus. And for your syllabus as well, for this syllabus, the coverage is only for maximum 2-point load only, so this is a load, the loads 10 kN and 10 kN, so there are two only, not more than two, and there is no UDL. So maybe if somebody have already studied this, you might have seen a UDL, like say 20 kN per meter. We are not going to cover in this syllabus. That one is on next semester 2. So I'm just gonna quickly, okay, so we're going to start with this question. All right, so we want to calculate support reaction first. So to do that, class, first of all, we need to redraw the question. So I'm going to like a very straightforward, simple redraw. We call it as, okay, so we have just redraw 10 kilonewton, then 20 kilonewton here. Okay, this is our point C, this is our point D. Okay, but for point A and point B, okay, we want to draw the load diagram. So this one, if you notice, we have the support, pin support, and then roller support over here. So we don't want to redraw that. We want to show the force, the support reaction direction. Okay, I have discussed in previous videos, so I'm just gonna straight away put down here. So we're gonna have RA Y here, and then RAX here. Okay, because it's the pin support is restricting for our beam to move left to the right horizontally, and restricting the movement of vertical movement. All right, so then now we have over here RBY, because this is roller support, so it's just restricting from going vertical movement, but not sideways. So there is no sideways, so that's why we're just gonna have vertical only. So why we put RAX and RAY? Y means for vertical, X for horizontal. A is the location, we have A and B here, and R is stand for support reaction, R. Okay, so R is why we don't know the value, so we put the unknown. We're just gonna give the unknown. So I'm just gonna look here, and then give the detail on the distance. So this is 2 meter. Is it 3? Yes, and then we have 4 meter here. Okay, now I'm gonna start with, so our beam class should always be in static. So when it's static, it means in terms of physics concept, it must be in equilibrium. So because we have a few unknowns here, so I'm going to explain you later on. We need 3 different equations. So 3 unknowns, we need 3 equations to solve unknowns. Okay, alright. I'm going to explain what I mean by 3 unknowns. Means that we need 3 equations. So you're going to understand this by the end of this video. Okay, so let's move on. So we're going to start with the first concept of equilibrium. We're going to start with total M at certain point. At any point, you can pick anyone, right? The bending moment in this beam here should always be 0. Otherwise, our beam will be like a wave, keep bending over here and here. But we don't want our beam in bend, so we must assume the bending moment at any place is 0. So that's why it's going to be 0. So you can pick any point. You can pick point A, point C, point D, point B, or even point at 1 meter, at 3 meter from here. You can choose that as well. But the purpose we need to choose which point is to reduce the number of unknowns. So because we have 2 unknowns here and just 1 unknown here, so I'm just going to pick this guy here as our main of reference. So I'm going to put MA. Okay, and then summation means the total, or the total support, the total bending moment, the net, right, the resultant moment, right? So that is what we mean by summation symbol. And then we want to add this guy here. What basically I mean is, we want to let the examiner knows that we assume clockwise positive. Okay, so you want now, once you already done that, you want to put imagine that you're putting your finger here. So let's see, so imagine that all this, put your finger there, and then all this arrow here is going to that direction. Okay, going to that direction. So notice that this is clockwise, and this is clockwise, and this guy here is anti-clockwise, so it's going to be negative. Okay, so moment come from the formula FD. So if you remember, M is equal to FD, so therefore we have force here. This is our force, and then this is the distance, so it's going to be, okay, we're going to start with our first load, 10 times with the distance 2 meter. I'm going to put down the unit as well in case. This 10 kilonewton from here times with the 2 meter, the distance here. Okay, so just gonna put that, and it's going to be positive because it's clockwise, and then we also have another positive 20 kilonewtons times with, alright, the distance not 3 but 5 meter from this point here, from our finger, so that's 5 meter. And then we have negative because this guy is anti-clockwise, right? And then we're gonna have 2 plus 3 plus 4, which is 9 meter times with RBY, and then should be equal to 0. Don't forget, equal to 0. Why this equal to 0? As I said before, we want to make sure that the resultant moment on our beam is always 0, so that it is in equilibrium. Okay, so you want to solve this, so we're gonna have 20 plus 100 minus 9 RBY. Therefore, our RBY is equal to, so I'm gonna quickly do the math. 20 plus 100, and then 120. Okay, and then bring 9 over here, and then put down 9 at bottom, so divide by 9. So we're gonna have 13. So just take 2 decimal place. Kilonewton. Remember kilonewton because we're going to get the force. This is the support reaction as a force. Okay, so just going to quickly change the unit. Kilonewton. Now we have RBY 13.33 kilonewton. So we want to complete RAX and RAY now. So we're going to start with another concept of equilibrium, which is total F must be equal to 0. So I'm going to use different color here. The force on the beam must always be 0. Okay, the total force acting on the beam must be 0, otherwise it's going to move. So we don't want it to be moving around, so we assume it's 0. But remember that the F can be horizontally and vertically, so we want to divide. So we have total Fx equal to 0. That's number 1. So over here we have RAX going to the right. We assume it's going to the right, so we have RAX. And then do we have anything else? No, we don't have any horizontal force. No, so if I have horizontal, it should be like this. But there is no horizontal force from the question, so we just gonna put there is no, so it doesn't add or divide minus with anything, so it's going to stick with 0. So you can just put like this. Okay, so this is for our Rx. Now for our total Fy, and this is equal to 0. Okay, so we're gonna have RAY going up, RAY going up, and then we have going down, okay, 10 kilonewton, because the direction of the load is going downward, support reaction is going upward, so it's positive, and then going downward for 10 kilonewton, that is, I'm just gonna put down the unit first, and then minus 20 kilonewton because it's going down, and then plus with RBY. Okay, so plus with RBY, and our RBY is 13.33, so I'm just going to put down the 13.33, and this should be equal to 0. Okay, let's bring it over here, and then just solve RAY. Therefore we're going to get RAY is equal to 10 plus 20 minus 13.33. That is 6.67, and don't forget the unit, kilonewton. And so that is for our support reaction at here. So RAY is equal to 16.67 kilonewton. Okay, now we have completed the question for support reaction. So the support reaction is the reaction on the support. So we have RAX equal to 0. We got, just gonna put down this guy here. We got RAY is equal to 16.67 and RBY 13.83. That is for the answer for support reaction. Now we want to draw the support reaction. Sorry, the shear force bending and bending moment diagram. So the rule is, class, you want to redraw the question. Okay, you want to use back the question here. I'm just gonna go and take the question here. Okay, let's copy that. Okay, so let's move on here. So I'm just going to quickly put down the value here, 16.67, and the value here, 13.33. Okay, so what we like to do is, let's put down here, to try and get draw a parallel line. Okay, going that way along all these point here, every point. Okay, and then we're going to have our first, we're going to draw a shear force diagram first. So make a line here for our shear force, just following the size of our question of our beam. So, okay, I want you to imagine that you are paying toll, membayar toll. You're paying for the toll. So, if you are having upward direction of load, means that you are getting money. Okay, so when I go getting money, if I make a graph, so shift diagram is actually a graph. So we're gonna have a straight line going up at the beginning of your journey. This is your journey. You want to go to this direction. You want to go to that direction until you get to B. So you start with 16.67. Okay, so you're gonna start with that, and then you keep going on. You keep moving here, but there is nothing, so you're just gonna have a straight line here. Okay, right? So sorry if it's not too nice, but it's a straight line there. But once you get to C, you're going to get minus. So because it's going downward, meaning that you are paying the toll. So over here upward, you get money, and if you're going downward, it means you have to pay for the toll. So it's going downward there. Let's assume about that. That is minus 10, and you're gonna have 6.67. So at the beginning you have 16.67 ringgit. Now after you get to C point, you have minus 10 ringgit. Let's assume like that way, and then we left with 6.67, and then we keep going on. C to D, there is nothing, so we're just gonna have a straight line there. But so this is still 6.67, but once you arrive at D, you deduct with 20, so you might have negative. You have to tell the cashier that you don't have enough money, so you're going to be in debt. So it's negative 13.33, excuse me. And then you keep going on from D to B, and then there is nothing, because there is nothing, no toll whatsoever. But once you reach B, you get some money. Okay, 13.33. So negative 13.33 plus with 13.33, that's going to be 0. So this is 0.0, this is 0.0. Alright, and that is for our shear force diagram. But just make sure you put down the unit. This is all kilonewton. Shear force is in kilonewton. If you still don't understand about shear force, please make sure you revisit, study the videos that I've given you before. And last but not least, class, for shear force diagram, make sure you label the positive side and negative side. So it's just like a graph. So anything positive side, we assume it's positive, and then it's negative. And that is for our shear force diagram. Okay, now we want to sketch our shear force, bending moment diagram. Okay, so now I'm just going to do the same thing. The unit should be in kilonewton meter. So why do we know kilometer? Because M is equal to FD, bending moment, come from this formula, FD. So F in kilonewton, M is in meter, so that's why we get this unit here. Okay, alright, so we're gonna start with 0 here and 0 here. So the rule is simple to draw the bending moment diagram. Okay, the rule to draw bending moment diagram, I'm just gonna give you the hack for now, is to refer, maybe I'm just gonna straight away state the whole thing. Okay, use area under shear force diagram. Okay, use that one. So for drawing BMD, use shear force diagram. So the area, so let's say we want at this point here. So at this point there is no area, and there is no area, so that's going to be 0. So we're just going to start with 0. And then if you move on, you got to point C here. You want to go and check every point C and so on. So if you put the area here, so this is the area, this is the area. So as simple as this is 2 meter, and this is the load here. So just times with that. So we're gonna have 16.67 times with 2, the area. So this is basic. So we're just gonna have 33.34. So we're just gonna label here. Okay, so maybe some of you might be confused. Sir, is it we should draw at the bottom or at the top? It actually doesn't matter, but for my preference, and I will explain you later on if we in a face-to-face session why I prefer to use this guy here going downward. Okay, but for our for my preference, it doesn't is going at the bottom, meaning that I always assume that positive for bending moment only. Positive is at downward and negative side is upward. This part here only for bending moment diagram. For shear force, as standard graph, positive at top, negative at the bottom. But for bending moment diagram, no. Okay, I'm going to explain it later on during our face-to-face session. Okay, now let's continue for this guy here. So I'm going to change the color so that you understand what I'm trying to say here. So now we want to draw we want to get the value for our bending moment for at point D here. So we just gonna use so this is our limit, so we just gonna use the area B4 here. So we're gonna have this area 1 plus with this area 2. So that one we're gonna have 16.67 times with 2 plus with 6.67 here. This is the distance. 6.67 times with alright, I think I need to use, you can use your calculator, but I'm just gonna calculate this one first. 6.67 times with 3 meter, and that is 20.201 plus with this area I have calculated, which is 33.34, and that would be 53.35. So we're gonna have here okay. Alright, and then we're going to calculate at point B. So actually, if you know, now we're gonna use this area here. So we're gonna at this point B, so we're gonna use the whole area. So basically we have 33.34 here, and this area is ending up just now, but the total basically is 53.35, but we have to know this area here. Okay, remember that it is negative. Alright, I'm just going to explain it. So this is 13.33 times with the distance, which is 4. Okay, I want you to notice that it's negative, so that's why I put negative there. You're gonna get negative 53.32, and then plus, because this is the area for negative side, and this guy here positive, so we're just gonna add with 53.35. 53.35 is the total area for this guy here. Okay, so that one is, then we're gonna get about 0.03, so that is close to 0. Okay, so it's close to 0, so we're just gonna put down that it's around that. Okay, all right, now because this is all point load, from all the question we just have point load, so you want to connect all these points here that we had in our bending moment here with a straight line. So I'm just have to take a ruler. Excuse me. So you want to use ruler. I hope you are basically next. So you want to make sure it's a straight line there. Oh, excuse me. And then just connect all the dots with a straight line. This is for bending moment diagram. Okay, so and then don't forget to label positive. Okay, so some of you might be confused, sir. Is it negative? Because it's downward. Okay, as I said before, for bending moment diagram, we use positive at going down, negative going up. For bending moment diagram only. And that is for your answer for bending moment diagram. And that's it for your syllabus, support reaction and sketch shear force and bending moment diagram. Okay, I hope this video come in handy. It helps you for your understanding, and please complete tutorial questions, the rest of the tutorial question for chapter 6.3. Thank you very much.